Okay, hello. Welcome to our webinar of today. The topic will be the live production monitoring and analysis in Steel Project PLM. I'm Colin MAYMON, the sales manager of the company. The duration will be, well, between 25 to 30 minutes, depends if I talk a lot or not. You've got a chat for questions if necessary. So here is a chart of all what we are doing in our software with all of our module and features. Today we're going to speak about the live production monitoring and production analysis in Steel Project PLM. The goal is to show you how we collect the data of the CNC machine, the manual workstation, and more important than collecting them, how we track everything in a 3D model, how we monitor the workshop activity, and how we analyze the performance at many levels. So for now, I will jump in the software, Steel Project PLM. Okay, so here is Steel Project PLM. Just for your memory, in November, we did make a webinar talking about the production manager. Today will be also about the production manager. We did separate the webinars in two parts. Part one was in November. As a reminder, you can find it on our website. There is an icon webinar. You can select your language here and the promotional webinar, and you will see all the webinar we've done yet. Okay, so the first part of the webinar I'm going to make today is here, production organization and follow-up in Steel Project PLM. So you can watch it. It's like the first part of this webinar. The second part will be now. So I will open Production Manager. I don't come back on how we do make the feedback in PLM. You can see that in this webinar here. I've got a ready model here with some feedback in it, okay? So in this model, you can see that we've got a part that has been sent, 82% in terms of quantity and 92% in terms of weight, a part which has been tooled, a part which has been assembled and controlled, painting nothing, shipping nothing. So here is the status coming from your CNC machine. As a reminder, from FeedShape CNC machine, all the feedback is done automatically in PLM. You don't have to do anything. It's fully automatic. With other kind of machines or with manual workstation as assembly, quality control, painting, we usually use our workshop assistant module. Okay, this workshop assistant module is made to collect the feedback of manual machines or manual workstation. Okay. Just opening it, just for you to have a view. Here you can select the machine or the manual workstation you want to feedback manually, and you can do it. The topic of today is not the workshop assistant. Once again, if you go in our webinar, we've got a webinar on the workshop assistant you can find here, okay? It's not here, but you can find it in English. And in promotional, well, we've got it here, workshop assistant, okay? So you can have a look how it works. So for today, as I was telling you, we've got some feedback which has been made in PLM. If I look at the phase at the assembly level, sorry, I will see exactly the same color codes corresponding to each assembly. So if I take this assembly, for example, and I look at the preview of it, I will see that a part has been sent and a part has been produced. If I look at this one, the same, okay, I've got information about the quantity sent, the weight sent, and so on and so on. If we look at this one, we can see the same. So if I look at this one, for example, and click on components, I will see which component has been sent and produced, as you can see on this one, P3, and which one has been sent and not produced yet. Okay. So you've got the status for all any single components here with color codes corresponding. Okay. What is interesting here is not only the color code, which is like an instant picture of the advancement of your production, but if you click right here, you've got a section called analysis. If I open analysis, I've got a bunch of things I can show. Okay, so first I've got the project name. I can see the nesting here. I can see that what has been produced in time, 6 hours, not produced, sorry. What has been produced, 7 hours and 8 minutes. In time, in weight, okay, in pounds here, what has been produced, not produced, and also in quantity in terms of components. You've got the same information about the fabrication job. So fabrication job, we made 2 fabrication jobs here, one for beams, one for plate. So we've got it in weight, we've got it in quantity, okay? So you know what has been nested and not nested. In terms of production, we've got the same charts. In terms of quantity, okay, so we can see that quantity not produced 293, produced 7, weight and time. Here we've got maintenance program. Okay, we did make a maintenance for 45 minutes on a machine. Okay, so this maintenance or this can be a cleaning or maintenance can be input to the customer and can be counted in the price of the project. So you can adjust those widgets by yourself. Okay, you can adjust them, take some off, add some. It's up to you. If I go on nesting here, I will see all the nesting I've made in this project. So if I look at my bar number 1 here, if I double click on it, I can see an estimating time here, comparison. I can see an estimating time of production, which was 17 minutes. And executed time of 48 minutes. So here we can see we've got a problem because we've got plus 30 minutes in terms of the of production. It means that it didn't took the time it should have taken. So here we can see there's a problem. Okay, you can see the composition of the bar and eventually all the alarms and messages popping up for this bar. If I look at bar number 2, here I open it. Comparison, 17 minutes forecast, 17 minutes executed. So here it's fine. The same for plate. Here, if I open a plate, okay, I will have the same kind of information, plus of course the composition of the plate and so on. So you can see easily here and compare the estimating time of production and the real time of production for each bar or plate. If I click on assemblies here, what I can see is for each assembly of my project, I can see the status of the assembly. What if it has been sent, tooled, what is the status of each of them? And when an assembly is ready to be assembled, it will appear in green light like that. So you will know very quickly in this table which assembled are ready to be assembled, because all the main parts and secondary parts are already produced on the CNC machine. If I go in parts now here, I've got a table showing me all the parts of my project. This table is showing, okay, all the operation or all the layout of your workshop with well, sent, tooled, assembled, quality control, painted, shipping, and the status of each component. So we can see here, for example, that on this one, B1, 8 has been sent in production, but 6 has been produced really, not assembled, not quality control, not paint, not shipped. Okay. For this one, it has been sent in production, tooled, assembled, and quality controlled. So you can very easily, for each components here, have a table which is quite visual to understand what has been done or not, what is the stage of production of each components. If I go on tooling here, I've got also each part of my project, part P1, part P7, part C4, and so on. What do I see here? If I'm looking, for example, at part C4, I can see that it's been through shot blast, cut, drill, scribe, assembly, welding, quality control, painting, and ship. Okay, I can see the quantity, I can see the estimating time, I can see the machine is been through, the quantity produced, the real time of fabrication, when it has been done, the date, and eventually the operator on the machine. So here you've got real traceability of which on these components, where it's been through, on which machine, which stages, when, how long it took, and who was the operator. If you have got some traceability idea coming up from an ERP, for example, you can see it here also. So for every single components, I've got this information and this traceability available. If I go in operation here, okay, you remember here, if I go back, I had a maintenance operation here. So if I go in operation, I can see that Colin did make a maintenance operation on the robot, which lasts 45 minutes. It was 17th of February. And okay, so all cleaning maintenance operation can be saved here and charged to the customer eventually. If I click on workstation, here I can see what is left, what is pending to complete the job. So here I know that I've got 144 pieces to be assembled, and I've got the list here. I've got 19 pieces to go through the robot to complete the production of this project, which represent 2.52% of the project. So it's what is left, okay, what is pending to complete the project. Here we can see on the Gemini, in terms of plate, no more plate to do. Okay, it's over. On the 1103 DVB, which is a redundancy, so three components, which represent 0.40% of the project. So you've got this information here. We also have a Gantt graphic. Okay, you can put the time period between 17 and 21. Here we will focus on 17 because that's when I did the feedback. With all your machines here on the left, and you will see, okay, that your drill and saw has been working from midday till 3:30. Okay, that you had an operation of maintenance between 3 and 3:45. That Colin here has been assembling some component on this project. So you've got a Gantt graphic in order to see what has been done on each machines. Stock traceability is in fact a traceability folder that we can edit in order to show the customer, to show your customer, or to keep for your own archives, a traceability folder with all what has been done. So I did generate the traceability folder. It will generate a zip file. I will open it here. Here it's here, Steel Projects PLM, traceability folder, it's here. So I've just generated right now. Okay, you can see 21st of February. This traceability folder, if I open it, it will look like that. Okay, I've got my project and I've got, okay, my component B1 is a profile of W14 by 30. It's been through the 1103 DVB and the robot. The material grade, it has been cut, drilled, coped, scribed, assembled, welded, quality control, painted, and shipped. It's a beam. Quantity, date, traceability number, eventually if you pull it from the ERP or whatever, and the employee. Okay, so you will have this traceability folder available for your customer in a zip file when you finish the project. You can give it to him or keep it for yourself also. Okay. Okay, so back in PLM. So as a reminder, it was a click-write analysis. All what we saw here was in a click-write analysis, okay? Now, we've got also a bunch of analyses up there. If I quit here, if I go in analysis here, I've got a bunch of analyses available. So I don't have enough data here in my computer to show you a good example. So what I will show you is some screenshot we've made from a database with more information. So here, what we can see machines. We can see the previous period, which was October, which is a line here, and the actual period, which is November 2022. So we can see that, for example, in October, this 1203 DDB from Fitchip machine did produce more than this month. Okay, same for this month, same for this month. So you can compare it with line here and with percentage here. We can also have alarm counted by workstation. So you've got all your workstation here, and you can have alarms. So alarms is in red, and messages are in yellow. Usually messages don't block the machines, like low oil or whatever. So you can have on a bunch of time, a period of time, here it's between the 1st of December to 31st of December, all the alarms for each machine. Okay, so we can see that, for example, this machine 1203 DDB was the one which was the most in alarm in this period of time. We have alarm and messages counted by day per machines. Okay, so on this machine 1201 FRC, sorry, in the 1st of December, we can see that we have 10 alarms plus a bunch of messages. Okay, same on a bigger period of time. Here, I think it's on 1 year. You've got the number of alarms. So every alarm has a name or identification, which is 250, 200, 202. Okay, so for example, for the alarm called 251, which does correspond to something, we have like 12 alarms during the year. Okay, the 250, we have more than 200 alarms and messages, of course. You've got the weight here, so period of time and weight in tons. Okay, so 2nd of November, more than 75 tons. Okay, and so on per days. You've got the total duration, same idea, days and hours. Okay, so per days, the total duration of production. You've got the duration per machine in percentage. Okay, so here it's in terms of percentage. We can see that the actual production time on this machine was 60%, and the rest of the time it was with messages, it was with milling time, it was, I don't know, ready to start without starting. Once again, it's in percentage here. It's not in per days. Here you've got the production on 1 month with a different kind of operation. That's I would say more complicated chart to read. You've got the number of bars produced by day. Okay, so once again, 2nd of November, 39 bars. 3rd of November, 49 bars, and so on. Same for tooling. So here the tool which has been chosen is drilling. So you've got the number of drilled per day. So if we look at this one, for example, we've got more than nearly 720 drill this day. You've got the number of parts which has been produced per day also. Okay, so once again, 2nd of October, sorry, like 10 or 12 parts and so on per days. Okay, this one is a bit complicated to explain. It's per employee, the efficiency of the different employees on project and per days. We had to hide some information because it's coming from a real example from a real customer. And we've got also this this one which is called the supervisor. So if I go back in PLM, I've got my supervisor just here on the right. Okay, the supervisor is like an instant picture of your workshop. So you cannot make any actions here. Okay, it's just an instant picture of what's going on where in your workshop. Which machine is an alarm? Which machine is working? If the machine is working, you will have a green arrow. Okay, which machine is stopped with a cross? If there's an alarm on the machine and the name of the alarm, the program running on the machine, the date of the last feedback of the machine, if the machine has been locked, by whom, okay, the employees and the items going through the machine. So once again, this supervisor is like an instant picture of your workshop. You want to see today 5:22 French hour, what's going on in your workshop, you click on supervisor, you have the instant picture. Once again, no action possible, it's just a picture. Okay, what I want to show you also is the kind of reports that can be made by the feature machine, which is quite complete. So here we've got a 603 DDB, which is a drill and saw machine. Period of time between the 21st of January to 2nd of February, on almost 3 days. So here it's in metrics, sorry guys, for the guys who are watching us in US, but you've got the name of the operator, you've got the type of profile going through, the length, when it started, when it ended, the time it took, and the efficiency of the machine, okay? So you've got a bunch for every single beam, you've got this analysis. And at the end, at the last page, you've got an analysis on this period of time of 3 days. So telling you that number of hours was 104 hours. The machine was off 24 hours and on 80 hours, okay? Out of the 80 hours here, the machine was feeding back information 73 hours. Feeding back can be production, but also can be tool setup, can be standby, can be alarm, can be stop with message, ready to start, okay? And the machine was really producing, cutting, milling, drilling, whatever, scribing, 57 hours. So out of these 80 hours, when the machine was on, it was really producing 57 hours, which give us an efficiency of 71%, okay? And the difference of time between 57 and 73 is here. Okay, it was in alarm 2 hours and 17 minutes, in standby 18 minutes, tool setup 2 hours and 15 minutes, nearly 7 hours in ready to start. So here we have clearly a bottleneck because the machine was ready to start, but no one did push a press button. So we lost 7 hours doing nothing. 1 hour and 30 minutes with messages, and nearly 3 hours with feeding the machine. So really, you can identify bottlenecks here and have the efficiency of your machine. That can be daily, that can be weekly, that can be monthly. It's up to you, okay? So those kind of reports are available with FeedShape Machine, again, because the FeedShape Machine gives feedback live to PLM without doing anything. Everything is transparent for you. It's a communication between the WinCN of the machine in the workshop to PLM, okay? So the last thing I wanted to show you is all those nice colors popping up in PLM are not only visible here on phases, assembly, and components, but if you import an XML from Tekla or an IFC from Tekla or whatever other software, IFC or XML format, you will be able to see these color codes back into the model. So if I look at my model here, it will open my model. Okay, so here it's with nothing, no feedback. If I click on feedback, I will see the same color codes. Okay, so once again, sent. Transparent green has been sent in production. Dark green, sent and produced. Red, assembled. Yellow, quality controlled, and so on and so on. So you can have, even on a 3D view of your model, all those color codes corresponding to the status of your production back into this 3D model. Okay, I'm talking since 25 minutes, so I think I'm reaching the end of my webinar here now. So once again, please don't hesitate to visit our website, okay? Which is here. You've got a bunch of webinars done in the past, which can be useful on other topics and other modules. And don't hesitate to send us some question or emails if you've got any question. That's it for today. Thank you for following this webinar, and it will be available in review in the next hour in our webinar section in our website. Thanks for everything.